Every time you plug in your phone, have you ever stopped to think, how on earth does that power actually get here? Well, it's not magic, that's for sure. It's actually this incredible engineering journey that starts hundreds, sometimes thousands of miles away. So today we're going to follow that journey, tracing the path of electricity from the massive power station right into the tiny socket in your wall. Let's get wired in.
So here's the plan. We'll kick things off with power's big adventure across the country. Then we'll see how it gets welcomed into your home. After that, we'll meet the safety guardians that keep you safe, figure out how everything gets connected, and wrap it all up with a quick knowledge check. Let's do it.
All right, first stop, power's epic journey, from the station all the way to your street. Our story begins right here, at the power generating station. You can think of this place as the giant beating heart of the electrical grid, just pumping out unbelievable amounts of energy. But here's the big question. How in the world do you get all that power across the country to your front door? It's a huge puzzle.
Seriously, think about this for a second. How does electricity travel for hundreds of miles without just fizzling out? I mean, sending electricity through that much wire, it's kind of like trying to push water through a super long, really leaky garden hose. You'd lose most of it along the way, right? So what's the secret sauce here? Well, the answer, and it's a brilliant one, is all about transforming the voltage.
Okay, so check out the scale of this journey. It's pretty wild. First, the power is generated at a hefty 11,000 volts. But for that long-distance trip, that's not nearly enough. So they use transformers to step it way up to a massive 132,000 volts. Then, as it gets closer to our cities, it's stepped down to 33,000 volts for local substations. And finally, for your neighborhood, it's brought all the way back down to the 220 volts that your stuff can actually use. It's this crazy up and down roller coaster of voltage.
So you're probably asking, why all the hassle? Why not just send it at 220 volts from the start? Well, it all comes down to one golden rule of physics: fighting energy loss. See, for the same amount of power, if you jack up the voltage, the current has to go down. And here's the really cool part. The amount of energy that gets wasted as heat in the wires depends on the square of the current. So if you cut the current in half, you actually cut the energy loss by 4 times. It's a massive saving, and it's the only reason we can send power over such long distances without it all just turning into heat.
Okay, next up, welcome home electricity. Let's talk about the 3 key wires. So the power has survived its epic journey and has arrived on your street. Now it needs to get inside your house. And to do that safely, it relies on a team of 3 really important wires.
First, you've got the live wire. And yep, the name says it all. This is the danger wire. It's the one bringing in all that high-potential 220-volt current from the street right to your appliance. Think of it as the main highway for electricity coming into your home. It's the one you absolutely have to respect.
Now, electricity can't just flow in. It needs a way back out. It's not a one-way street. That's where the neutral wire comes in. It's the return path. It completes the circuit, carrying the current back to the source. And it sits at 0 volts, so it's the neutral party in this whole operation. Without it, nothing would work.
And last, but definitely not least, we have the earth wire. This is your personal bodyguard. Seriously, it's a safety wire connected directly to the ground. Most of the time, it does absolutely nothing. It just sits there, carrying no current at all. But when something goes wrong, this wire becomes the hero of the story and can literally save your life. We'll get to how it does that in just a moment.
So how do you tell these 3 wires apart without getting a nasty shock? Well, that's where color coding comes in, and it's super important. Now, there was an old system, but let's focus on the new international one you need to know. Live is brown, neutral is light blue, and earth is green, or sometimes green and yellow. You absolutely have to know these. It's not just for an exam, it's a critical safety rule. Brown is danger, blue is neutral, green is safety.
Okay, number 3, the safety guardians, fuses and switches. Speaking of safety, let's talk about the unsung heroes hidden inside your walls. They have one job and one job only: to protect you and your expensive gadgets from things going wrong. Let's meet them. This is a perfect example of old school tech versus new school tech. On one hand, you have the classic fuse. It's basically just a thin little wire designed to be the weakest link. If too much current flows through, it literally melts and breaks the circuit. It's a one-time hero. You gotta replace it. Then you have the modern MCB, the miniature circuit breaker. This thing is way smarter. It doesn't melt. Instead, it uses the magnetic effect of a current surge to automatically flip a switch off. The best part? It's reusable. The power goes out, you just go to the box and flip it back on. No fuss.
So, how do you pick the right fuse for the job? It's kind of a Goldilocks situation.
The fuse rating needs to be just a little bit higher than the current your appliance normally uses. If it's too low, it'll blow all the time for no reason. If it's too high, it won't protect your appliance during a surge. So, look here. A big electric oven that pulls almost 14 amps needs a 15-amp fuse, but a little 60-watt bulb that only uses a quarter of an amp, a 5-amp fuse is more than enough. It's all about finding that perfect balance.
Okay, this is a super important safety question. Why does a fuse or a switch always have to be on the live wire? Well, imagine this. If you put the switch on the neutral wire instead, yeah, flipping it would turn your lamp off, but the lamp itself would still be connected to that 220-volt live wire. It would be off, but it would still be electrified and incredibly dangerous if you touched it. Putting the switch on the live wire guarantees that when you turn it off, you are completely cutting the appliance off from the power source, no exceptions.
Let's move on to number 4, connecting your world the right way to wire. So we've got safe power coming into the house. Awesome. But how do you connect everything, all the lights, all the outlets, so that they all work properly? Well, there is definitely a right way and a very, very wrong way.
This is such a critical point. So you've got two options, series or parallel. If you wired your house in series, think of those old cheap Christmas lights, it would be a total nightmare. First, all your gadgets would have to share the 220 volts. So your TV might get 50 volts, your fridge 70, nothing would work right. And even worse, if one single light bulb burned out, the whole circuit would break. The entire house would go dark. That's exactly why we use parallel circuits. In parallel, every single appliance gets its own personal connection to the full 220 volts, and they all operate independently. You can use your toaster without worrying if the TV will turn off. It's the only way to go.
All right, we've made it to the end of the journey. Time for our final section, test your knowledge. It's time for a little quick-fire revision to see what stuck. You ready? Let's do this. Question 1, and it's a big one for safety. In the new International Convention, what color is the live wire? I'll give you a second. Got it? It's brown. That's right, brown for the dangerous one.
Okay, next up. Why do we connect appliances in a house in parallel and not in series? Give me one good reason. Thinking? Well, the main reason is so that every single appliance gets the full 220 volts it needs to run properly. A bonus reason? They can all be switched on and off independently.
And what about that silent bodyguard, the earth wire? What is its main job? Its whole purpose is to protect you from getting an electric shock. If a live wire accidentally touches the metal body of, say, your washing machine, the earth wire gives all that dangerous current a super easy path to the ground, which blows the fuse and keeps you safe. It's a lifesaver.
And to wrap things up, here's a final cool little detail to think about. Have you ever really looked at a 3-pin plug and wondered why that top pin, the earth pin, is longer and fatter than the other two? Well, it's actually a genius safety feature. The extra length means that when you plug it in, the earth connection is made first, before the dangerous live pin connects. And when you pull it out, the live pin disconnects before the earth pin does. It's a simple idea that guarantees your appliance is safely earthed for the entire time it's plugged in. The safety connection is always the first one in and the last one out. Pretty clever, right? Just a perfect little piece of everyday engineering that keeps us all safe.